Okay, so today we're going to talk about chapter 7. And in chapter 7, the important concept here is about arrays. So, it's a type of data type that can handle multiple values, right? So in this chapter 7, we'll be separating it into uh, several sessions. So we'll start off with a single array, right? A data type with a single array, and we'll explore on how to initialize it and how to use it in your programming. And we'll start off with multiple arrays, right? So, let's go on to the slides. So here we're going to talk about single dimensional arrays. So we'll start off with this one and we'll continue to talking about two-dimensional arrays. All right. So for the single dimensional arrays or one-dimensional arrays, in this chapter basically we'll talk about how to initialize them and how to have them as an argument in your function or in your code. Right? Now, a one-dimensional array is a single-dimensional array or a vector, right? It's basically a list of related values. So we have a bunch of values that we want to put together, right? And uh, we will be defining an array, right? For example, here, right, we have a list of student grades, 98, 87, 92, 79, 85, right? And when we put them all together, it has to be of a single or the same data type, right? And all of this data will be put into or stored as a single group in a specific name that we give it, right? An identifier that we'll give it, right? So, in this case, example here, then we would have a data type called integer with a name, maybe we can call it grades, right? And all of these values would sit into grades, right? Bear in mind they all have to be integers, so right? So array declaration statements basically provides the array name itself, right? The data type and the number of items that the array can store, right? For example, the syntax here would be the data type, array name, and the number of items, right? So here you would put in the case of doing the grades earlier, right? So it will be integer, and here would be grades, that the array name, and number of students that are available. So if you have 32 students, you put 32 here, right? So your particular one-dimensional array here is called grades, and grades are able to handle 32 integers to be stored, right? Now, it's a common programming practice. Usually, you will have the number of items as a constant during the declaration, right? So you would have an integer, a constant integer, for example, number of items, num items equals to 10, for example, right? So this value actually doesn't change, right? Okay, so let's look at how this is being done in your programming. So remember I said you have to do the constant first, right? So for the number of values that you want to keep in your arrays, right? So you would have a constant integer num equals to 10, but this basically defines a constant array size. And then you would say the data type integer, and you want to keep values, for example, then values num, right? So values is able to keep 10 integers, right? You can have other array variables in your programming. Suppose you want to keep characters, then you would start it with char, right? And also define it the same way. If you want a array with the data type double, then you would initialize, you would declare it with the double statement, right? So this is basically how you would declare an array in your programming, right? So if you look in a one-dimensional array, everything is kept according to their index. So that's going to be the position of where it is kept, right? So you can consider it like a bunch of blocks right next to each other like this, right? And the first storage here will be index 0. The array starts at 0, so everything is counted from 0. And then 1 would be the second block, 2 would be third block, 3 would be the fourth block, right? And this is basically what we say the array length. So when you declare something to have an array of the size 10, then basically it would have an index from 0 to 9, right? And you can access that element by basically stating which index you want to access, right? And arrays are basically stored sequentially, right? And it's kept into this index, right? So one-dimensional array, if you're calculating the size of how much you will use in your programming, right? It depends on the data type that you basically define. So if an integer is 4 bytes, then you have a size of 6, then you would times it by 6, you will have 24 bytes. A character, on the other hand, would have 1 byte, so if you have 4 characters, that would be 4 bytes, right? So keep that in mind, right? It really determines on how much space you're using in your programming, right? Okay. So whenever we're doing a one-dimensional array, right, you can assign values by basically just putting the indices that you want, right, index value that you want. So if you want to say put a grade in the 0 part here, right, you would refer it to be index 0, right? And this would put the data basically in the first index, right? And if you want to put it in the second index, you put grade 1, right? So you can also access grade values by determining the index number, and you can do numeric operations, mathematical operations with it, right? Okay, so all data according to this. So if you have grade 3 here, that basically specifies the fourth element in your array, right? This is basically how it's being done. It will skip all the first 3 and go straight to the fourth element, right? All right. Okay, so when we're talking about subscripts, basically the square bracket that we're using, right? If we do not have if it doesn't have any integer, you can basically put any expression in there, right, that can be processed to be an integer, right? For example, here we can put into the subscript a variable form, for example, grade I, right? So, or grade 2 times I, or grade j minus I, right? So these values inside here will be evaluated, and the computer or the compiler will decide, or during execution, whether this is a 0, whether this is 1, whether this is 2, right? So we'll look about how this is going to be used in the next session. We'll end this session for now, and we'll continue and see you back in a few minutes. All right, see you later then.